Alright, so in this problem, I'm given that a squared minus b is equal to 43, and b squared minus a is equal to 43. So this is a system of equations, and I'm going to first start, because both of these equal 43, if I subtract them with each other, then I should get 0, because 43 minus 43 is 0. So now we have this equation to solve. And to solve this equation, I'm going to first start by distributing the negative sign. So I get a squared minus b squared plus a is equal to 0. And now if I switch the order of this, I get a squared minus b squared plus a minus b is equal to 0. And a squared minus b squared, that's equal to a plus b times a minus b. And I have this plus a minus b is equal to 0. Now if I factor out a minus b, I get a minus b times a plus b plus 1. So now this gives me two equations. I get a minus b is equal to 0, and this means that a is equal to b, and I get a plus b plus 1 is equal to 0. And this means that a is equal to negative b minus 1. Now, remember how we can choose any of these equations. I'm going to choose the first one, and I'm going to write it over here. So I have a squared minus b is equal to 43. And now that we know that a is equal to b, I'm going to rewrite a as b. So I get b squared minus b is equal to 43. Now if I subtract 43 on both sides, I get b squared minus b minus 43 is equal to 0. And if I put this in the quadratic formula, in this case, a is 1, b is negative 1, and c is negative 43. So I get positive 1 plus or minus the square root of 1 minus 4 times 1 times negative 43 all over 2a. And now this is equal to 1 plus or minus the square root of 1 plus 172 all over 2, which is equal to 1 plus or minus the square root of 173 over 2. Meaning that a is equal to this, and so is b. So this is one solution of our system of equations. Now, for this equation, we get a is equal to negative b minus 1. And remember how we had a squared minus b is equal to 43. This was our first equation. And using this equation, I'm going to rewrite a as negative b minus 1. So I get negative b minus 1 squared minus b is equal to 43. Now to solve this, negative b minus 1 squared, that's the same thing as negative b squared plus negative 1 squared plus 2 times negative b times negative 1. And then we have our minus b is equal to 43. Now negative b squared, that's simply equal to positive b squared. Negative 1 squared is just positive 1. Now I have this plus negative 2 times negative b is 2b. And we have this minus b is equal to 43. This equals b squared plus b plus 1 is equal to 43. Now if I subtract 43 on both sides, I get b squared plus b minus 42 is equal to 0. Now I'm going to rewrite b as 7b minus 6b. And the reason I did that was because now I can factor by grouping. So from b squared plus 7b, the greatest common factor is b, so I'm going to factor out b, so I get b times b plus 7. And from negative 6b minus 42, the greatest common factor is negative 6, so I get negative 6 times b plus 7. Now from here, I'm going to factor out b plus 7, so I get b plus 7 times b minus 6 is equal to 0. And now this gives me two equations. I get b plus 7 equals 0, and I get b minus 6 equals 0. So for b plus 7 equals 0, b is equal to negative 7, and for b minus 6 equals 0, b is equal to 6. Now, we aren't done yet, because remember how we said that in the beginning, a is equal to negative b minus 1. So if a is equal to negative b minus 1, well, in the case of b equaling negative 7, I get a is equal to negative of negative 7 minus 1, meaning a equals 7 minus 1, meaning a equals 6. And in the case of b equaling 6, I get a equals negative 6 minus 1, meaning a equals negative 7. So we have a couple different solutions here. So our first one is a equaling 6, and when a equals 6, b equals negative 7. Our second one is a equaling negative 7 and b equaling 6. Our third solution is a equaling 1 plus the square root of 173 over 2, and b equaling the same thing. And finally, we still have the negative part, so we have a equaling 1 minus the square root of 173 over 2, and same with b. b equals 1 minus the square root of 173 over 2. So these are our 4 solutions to the system of equations. And remember, a system of equations always has the value of one variable and another variable, so it's not just one single answer.